you don't know what Gradle is a build tool, and it's easiest to describe it as a build tool for the JVM. Now, the most recent release of Gradle, 1.8, now has kind of fully supported C, C++ assembly language building features. So it's easy to describe Gradle as a build tool for the JVM. It's also now kind of a lie. It's just a build tool. But it's grown up in the Java space to compete with DubJUG. What are the two big build tools of the Java world?
Maven
and Ant, yes. So, and if we think about why Gradle, that first bullet there, let's just talk. Early on, Gradle was often described as some kind of compromise between the Ant approach and the Maven approach. Okay, the Ant approach was very imperative. The only model you have in an Ant build is a grouping of things called a target. You have a target, and a target contains a step-by-step description of the actions to take. To execute a compile target, you make a directory and you run javac, and then maybe you do something else. That's it. That's what Ant is, step by step by step. So it's like your programming, but you didn't have looping or conditionals, and you didn't really have variables the way we think of variables. So it was everything bad about programming, nothing good about programming, plus XML. That sounds like a win. And we kind of know, give me more of that. Let's just stop right now. Plus, builds tend to grow was something that we discovered. A simple Ant build was maybe a few dozen lines of XML, and then a complex enterprise build 5 years later is 3,000 lines of XML. So it doesn't really do a good job managing complexity. Maven, it also doesn't do a good job managing dependencies, which we realized were a problem. Maven now entered the scene trying to fix both problems with a different approach. In my opinion, Maven did a really good job fixing the dependency management problem. Now, there is no good dependency management solution. There are various no good dependency management solutions. Dependencies are hard no matter what. The Maven approach ain't that bad, in my opinion. I think that was a good innovation, and Gradle respects all that and is perfectly compatible with Maven-style transitive dependency management. So you got that. Maven did a good job at that. And otherwise, philosophically, Ant says, man, I don't know what a build is. Just go do stuff. Maven says, I'll tell you what a build is. A build is this set of 23 steps that I'm going to take one at a time, and I'm going to let you fill in a form to tell me what parameters, how I should parameterize each one of those steps. A build is a form that you fill out. In Ant, a build is a blank canvas. Both of those are the wrong approach to managing complexity. So Gradle isn't really a compromise between Ant's imperativeness and Gradle's declarativeness. Really, that's not what Gradle is. Gradle is a set of APIs. It's a software development platform for you to code builds. See, its belief about a build, Ant doesn't have an opinion about builds. It's just kind of going, well, whatever. Maven thinks a build is this thing. It's a form. You fill in the form. Gradle says a build is code. And if you're writing a build, you're a software developer. You're a professional. You code stuff. You use APIs. And you want to use the APIs that are appropriate to your task, that expose the right abstractions for you to get your work done in a reasonable way. That's what Gradle tries to be. So the kind of builds I'll actually show you here, I'm going to live code some builds. We'll take a look at them. They'll be pretty simple. Simple builds are easy to write. They're very declarative. You just configure some stuff. But at some point, that's not true anymore. Your build is complex and custom. And I think the world that we're entering is a world of more complex, more custom builds as more and more automation gets poured into the delivery pipeline. You don't just want a WAR file anymore. You want running software on servers when you press a button. You might have to write a lot of code to do that. And Gradle is a platform that respects you as a professional and gives you the tools to get that done. Now, as a result, really being good at Gradle takes time. There's a lot to learn. Doing simple builds with Gradle, you'll go away knowing how to do that tonight. Being good at writing custom plugins, well, that's tough because builds are tough. And it's just a tool that makes them a little bit easier. So philosophically, that's what Gradle is. Let me show you some code. Start with the basic the basic task model. And is everybody basically able to see that? I think so. Good. If not, watch the video. It'll be clear on the video. The basic unit of activity in Gradle is a task, and in Ant, that's kind of this crass little collection of some targets, or pardon me, in Ant it's called a target, which is a crass little collection of some tasks. In Gradle, a task is an object, and it's an object that we can program. It's got properties and methods, and we can call those things. Now, LSAT, that would be interesting. It'd be a satellite task. A Gradle task has a built-in list of actions. When that task runs at build time, those actions get performed. The job of the build is to configure the tasks to do the right actions. Now this task here isn't anything in particular, it's just the default task. It doesn't have any built-in action, so we have to give it some. I'm going to append to that list of actions this closure. Now if you don't know any Groovy, you might not recognize this. This is a thing called a closure. Java 8 is going to be called a lambda. The syntax is, vaguely similar. It's just a little, it's like a combination between a method and an object. It's a little piece of code that I can pass around as if it were an object. So I'm going to give this hello world task something to do, and you're not going to see this one coming. Yeah, that just happened, folks. All right, that's what this task is going to do. It's going to print hello world. So let me go out here, and I'm going to ask Gradle. Oh, by the way, where am I? I'm in the tasks directory. Build.gradle is right there. Let me, I'm getting confused by my prompt. We can't have that. There you go. Build.gradle is right there, and I'm going to run the hello world task. And it works. Yay. We've said hello. You can go now. I can ask Gradle what tasks it has. It always has a number of built-in tasks. These are just there implicitly, built into Gradle, including the one I just ran. And now we see hello world is there. It's a lot less exciting than the other tasks. It's just under this prosaic other label, and it doesn't have any documentation. But that's okay. I can program that object to have those things. Like I can put it in the group Dublin JUG. Now you notice down here I use double quotes, and down here, up here I use single quotes. It's because it's groovy, and I can do that. And description, say hello to the world. Oops. That is, of course, not a valid task. Shrink up the bottom of that window a little bit. Now we see the Dublin JUG tasks are up here in a nice organized way. I love it. And there we are. Just to make sure everybody can see everything that's on the screen, that's simulated stadium seating for you by bringing up that bottom part. Okay, dependencies real quickly, just to kind of get this idea in our head of how these things relate to one another. I've got a lot of refactoring to do. This is really an ugly build I've got here. A cleaner way to do this is like this. And let's just take those things away. Looking good. There we go. So when I've got a bunch of configuration to do, and that's what I call this in Gradle, when I'm setting the properties of some object, some domain object in my build. In this case, that domain object is a task. When I'm setting properties and calling methods on a domain object, I can group all those together in this so-called configuration block. All right, because I'm configuring that object. And that's really what a build does, is it first goes through this phase called configuration, where all of this groovy code runs. This is a groovy program. During that configuration program, or phase, this groovy program that you're looking at is compiled and it executes. The output of that groovy program is a graph of these task objects. So the purpose of the build is to set up internal Gradle data structures that Gradle can then walk, particularly the tasks, it'll walk the graph of tasks and figure out what actions to execute for all the tasks that are supposed to run. So there's configuration and there's execution. This code right here is the only actual build time code that executes. When I run hello world, that's the line that runs. When I run Gradle and it finds this build.gradle file, all that code runs to configure things. So let's see, I've got world now, and it's going to print line the word world. Let me hack this up a little bit here, so it'll just say hello. So hello says hello with no new line. World says world, and let me be a nice guy and put those things in there. Oh wait, there we are, Gradle tasks. So we have hello and world. Now, I can run Gradle hello, and it does what I'd expect, and I can run Gradle world, and it does what I'd expect. Now, again, let me give us the -q flag just to keep that output clean. What I would like when I run world is to set up a dependency. I'd like world automatically to depend on hello. So now when I run world, it'll be careful to run hello first, and I get that same awesome functionality. This is probably the hardest way to write hello world that there is. You might, further research might produce a more complex program. This is close, but you get the idea. You see that a Gradle build, number one, is a groovy program, period, and it consists of domain objects that we configure, and that's a technical term in Gradle. We configure these, in this case, task objects. As our build gets more elaborate and we add plugins like I'm about to do, the number of types in my domain object universe and the number of active objects is going to increase. So as a programmer, I'm going to have to keep track of more types and more objects. That's not such a bad thing. Let's see here, if I could just bring up the Gradle documentation. We got a nice fast internet connection here, and that's the wrong thing to do. I will click on the, oops, whoa. I will click on the documentation link. If I wanted, finding the DSL reference here on the Gradle website, if I wanted to understand the types I'm programming, the objects I'm programming here, I would look in this language reference, the Gradle build language reference. Down the side, in particular, I've been talking about tasks. So there is core types, task right there. Task is a type. I get a nice narrative describing what that is, some examples of how to create one, and then down at the bottom, I see a list, or not at the bottom, in the middle, I see a list of that object's properties, and further on down, that object's methods. So in the DSL reference, I get proper API documentation of all the things I'm going to program. I might refer you back to this a couple of times if there's anything we need to check, but when you're using Gradle, you've got this thing in your face. This is a tab that's open. And before long, usually when you're using Gradle, you're going to drill down to this documentation, you'll click on things, you'll say, okay, what's that do? That's got this thing. And all of a sudden, you're looking at Java docs before very long. And that's not a sign that the documentation is incomplete. What kind of person are you if you're reading Java docs? You're a programmer. That's right. Okay, so as a Gradle user, as a sophisticated Gradle user, you're acting like a programmer. So don't worry about the Java docs. It's just how it is. And that's, in Gradle's opinion, the right way to approach a build. But let's look at a simpler build first. This was unnecessarily complex just to kind of show us the data structures, but I would like to take you into a Java project. I've got a little bit of templated Java code here. Let's look at my project directory structure. I've got source, main, Java. That's a nice standard Maven layout for Java code. That's the default in Gradle. If you don't like it, you can change it, don't worry. And under that, my package structure. And in this case, it's a package called com, no fluff poetry. And there's this Java program down there, Java class file called poetry emitter. And I'll just shrink that up a little bit. Now, I'm going to need to create a build file, so let's go ahead and do that. And that file is going to be called build.gradle, and it is at the top level, so it's a peer to the source directory. Build file at the top level. Let me take you on a quick walk through this code, just so you know kind of what it does. I'm going to run it a few times. We're going to play around with it a little bit. The class is called poetry emitter, and we'll scroll down to the bottom and we see it has a main method that constructs a new instance of itself and calls a method called emit. Now, emit takes a list of strings, loops through them, and prints them out. It's amazing. Years of research. Absolutely incredible. So, hundreds of pull requests. All right, the data comes from, in this case, a method called po, which is up here. Here we are. It creates a list of strings and adds strings to that list and returns it. I think you kind of get the point. Now, if this were Ant, we'd need to decide how we were going to represent the location of the source file. Normally you make like a property for that, and where do the class files go, and how are you going to run the compiler, and what are the option switches, and you probably need a target for tests, where the test's going to be, have I compiled the application code yet, where does my test framework come from, what's the class path for Java-C for my test code, am I going to format the test, am I going to make a jar, do I need a clean task, or clean target, stuff that you'd have to write, and you'd copy and paste it from somewhere, but fine. Let's see the Gradle way to do that. The Gradle way to have a Java build looks like this. I'm going to write apply plugin Java. And that's it. I like a new line afterward. I think there should be a trailing new line. And I guess there, I could do it this way because it's groovy and I could use double quotes. In this case, it doesn't matter, and I like my non-interpolated string literals to have single quotes, so there we go. That's it, and all kinds of crazy things just happened. Remember before when I ran tasks, I just saw like there were half a dozen tasks built in? Well, now that this is a Java plugin, it's big. I've got these 6 build tasks. Automatically make a jar. Build everything, including the tests. Clean, that exists. These help tasks, run the tests only, all these things. Now, there are even more tasks than that. Gradle is actually hiding some from me because algorithmically it doesn't think I need to worry about them. But I can see, for example, that test runs a task called classes. I didn't even see that in the list before. That depends on something called compile Java and process resources. All of these things exist because I applied that plugin. So applying a plugin takes this rather simple object model of the project and enhances it in a build-specific way. So I kind of like the look of compile Java. If you don't mind, I'm going to run that. There's not much to my project. I'm going to run Gradle compile Java. And actually, if you want to be cool, if it's camel case, you can just do that at the command line. It's idiomatic in Gradle to give your tasks camel case names. So on the command line, it lets you do that thing. And hey, that was successful. My code works. That's awesome. And now we have a directory called build. If you use Maven, target is the default name of the directory where all your stuff goes. In Gradle, it's called build, and it looks like this. Just having compiled the Java gives us build classes main, and then our package structure and the class file. So I could run that now. I could say java-cp build classes main is going to be my class path, and then com no fluff poetry emitter. I'll clear the screen. We'll see what it does. It works. Woohoo! I could change that to, let's say, do Shelly instead. I'm going to have to rebuild, recompile the Java code. And there's Ozymandias. So we can build Java code. And the good news is it doesn't take a lot of work. When everything is standard, it's a one-liner. So a typical thing that comes up as kind of everybody's first question is, how does it do dependencies? Well, there's a chapter in the book on dependencies, and there's so much to that story. I can connect to Ivy repositories, and if I'm going to talk to an Ivy repository, of course, the directory layout is not standard. We can't count on that. So there's a DSL for describing what the directory layout of that particular Ivy repository is. I can connect to a Maven repository. That can be Maven Central. That can be an internal Nexus or Artifactory or some other Maven repo out on the internet. If there are credentials that I need to give it to be able to connect to the repo, there's part of the DSL for specifying those credentials. Let's go for something simple. All right, let me introduce a dependency into the code, and then we'll put that into the build and see what happens. Now, I've got some stuff baked in here. This line is commented out. This is an import of Commons codec, the base 64 codec in the Apache Commons codec library. You were hoping that you'd see some base 64 encoded Shelley. Well, today's your lucky day. Now, I have to change this emit method. Instead of just printing out the line, I'm going to call the encode method now. And that encode method also needs to be changed to actually use a codec, which it now does. It's going to create a new base 64 codec and encode the bytes and turn that back into a string. So now, let's see, I'll go, I'm going to use a different class just for grins. I'm going to run classes. And let's see what classes tells me. We are here. Okay, it tried to run compile Java, and that failed, obviously, because it doesn't know where to get base 64. That's not a thing right now. That's a dependency. Let's go introduce that dependency. You do that in a block called, famously, dependencies. Things get crazy in here, in this block. There's a whole chapter on how to do that. There's plenty of documentation. Let me make it something simple. I'm going to say we have a compile time dependency on this thing, Commons Codec 1.6. This is a standard Maven style group artifact version vector. So if we know what repo to go look in, what Maven repo to go look in, we'll be able to find that thing. This word here is a little bit of magic. That's what Gradle calls, it uses a somewhat obscure term, a dependency configuration. Now, you want to think of that as a bucket of files. It's a bucket of files named compile. What Gradle is going to do is it's going to go to a Maven repository, resolve this dependency, which means it'll go look up a POM file and grab that metadata, download that POM file, process it, and that POM is going to tell it what jar file do I need to get, what module do I need to get for this thing, and then what other things does this depend on. So what are the transitive dependencies of Commons Codec? As it turns out, sometimes I give this in places where I can't rely on the Wi-Fi, and so I intentionally picked something that's a very small jar, really easy to use, and has no transitive dependencies. So it's not going to do a lot of work. If this were, Spring Web or something different, there's some dependencies. And that's a good thing. It's good to rely on each other, right? I mean, you don't want to redo everything. So dependencies aren't, well, they are an evil, but they're a good as well. It's complex. Anyway, it's going to go resolve that. In this case, it's just going to get one jar, but it might have gotten 100, and all of them are going to go into this named bucket called compile. A minute ago, I executed a task called compile Java. That actually runs Java-C. It's going to fail if this jar isn't in the class path. So the compile Java task, which you don't see, that's a good thing that you're not looking at the code for that right now. That's all embedded in the plugin. That compile Java task will go execute Java-C, and it will go look in this bucket of files and jam all that stuff in the class path. So that's a nice abstraction to manage that collection of dependencies. And again, I simply don't know a priori how many jars that expression evaluates to, and I don't care. It's a compile time dependency. Now that still won't work because I need repositories, yes. I usually mistype that or like dependencies or, yeah, they're, English is hard. So, repositories, Maven Central, I don't need to give it the URL, that's baked in, it's a convenience method. Of course, I could just define a Maven repository and give it a URL of, yeah, I know. No, that's actually not. That's the way that's what the name of the repo is. I'm in charge here. All right. No. And this URL, pardon me, this DSL gets rich. Again, as I said, I might disable transitive dependency management. I might have to say, you know, hey, there's a particular artifact where this version should win over this version. I'm able to elaborate on that here. But not gonna. Right now, I just want Maven Central. That is good enough. Oh, wait. Yeah. This is where I put IV definitions. And, all right, what if you're a crazy person and you're kind of in the middle of a transition from my old Ant build where I had a lib directory with a bunch of jars in it. That's how it used to be. But I've got some managed dependencies on top of that. Like, go get some stuff from Maven unless you find it locally. Then don't go get it from Maven. Oh, that's okay. Flat dir. No, it's like dir lib, something like that. There you go. So I'll say, go look in the lib directory first. If you find it there, great. Otherwise, go on to Maven Central. So you're not constrained to just one method of dependency management. However, this build is going to work, I think. I will run the classes and see what happens. One thing I would point out, when I run it again, it knows my Java code is up to date. It doesn't have to run that stuff again. Under the covers, there's an incremental build engine that automatically applies to any of the built-in stuff, any of the plugins that come with it. If you need to write your own custom tasks or make your own plugins, it's very, very simple to engage this incremental build engine. Basically what it's doing is it's hashing all of the input files and the contents of the output directory in this case. And when the task starts up, before it tries to do any expensive work, it'll check the hashes on those files. And if they have changed, it will only run on the files that have changed. Big time saver for big projects. And it's possible, as I said, to engage that on your own things. Once I wrote a custom task that took as input a single Groovy file. It was this Groovy DSL I'd written for a customer, and it output a bunch of generated Java code. So if that one file changed, we'd want to re-emit the Java code. Or if any of the generated Java code went away, we'd want to re-emit it. If the file didn't change, we didn't want to bother. So it was very simple to hook up the inputs and outputs and make the incremental build engine work. I didn't really have to interact with its details at all. The interface is simple when you're being a programmer. All right, so we'll run this guy again, and this is going to work, right? Wrong, because where is org Apache Commons Codec? What do you think? Yeah, I'd have to doctor up the class path. Where should I look for that? Anybody got a guess? Lib, no. M2, who said M2? Okay, wrong, but close. So close. Yeah, M2, if you don't use Maven, M2 is where Maven caches the stuff it downloads. So it finds things out in Maven repositories, downloads it, caches it in a directory called .m2 in your user home. Gradle uses a directory called .gradle, because you'd like 2 copies of all that stuff. Actually, this is a good thing. Let me just riff on this for a moment. So the idea is that sort of the primary key, the individuator of this artifact is these three parameters: group, name, version. And if I know the group, the name, and the version of a thing, it doesn't matter what repo I resolve it from, that's a unique identifier. And any jar I get from any repo called Commons Codec 1.6 is always going to be the same jar. I can just get any of them and cache them and I'm fine. Doesn't matter if I got it from a different repo the last time I built, I've got it cached, I'll go for it. And I mean, I want to live in a perfect world too. I think that sounds great. It just isn't necessarily the case. In our experience, looking at real-life enterprise builds, sometimes people forget to bump the version number when they push a new build of something, and there might be one repo that has one version and one repo that has another. And I know it's bad, but we just kind of have to deal with that fact. So one of the big reasons that Gradle doesn't use M2 is because M2's cache is insufficiently sophisticated. The .Gradle cache uses these three parameters, group, artifact, version, plus basically a hash that represents the repo that the thing came from. So the actual primary key is repo, group, artifact, version. And that's safer. That leads to more repeatable builds. Leads to more stuff that gets cached, but the other option is it breaks. So we'll go with the idea that disk space is cheap. And with respect to the size of typical build cache or build artifact caches, it's not a problem. All right, so I could go look in .Gradle, let's see, caches, and etc., and I'm not going to because that's silly. I'm going to write a task to do that. And I'm going to tell you about a new feature of tasks, and that's types. If you just create a task like we did before, it still has a type. It's called the default task, and it doesn't have any built-in behavior or very many interesting properties. Java exec is a much more interesting task type, and it does have a built-in action. That built-in action is to go fork a JVM. Well, that JVM is going to need a main class to execute. It's going to need a class path. Those things are now declarative properties. It's got a main method. It's got a class path. Now I've got a nice little hack here that, class path. That's a property that Gradle is maintaining that contains two things. Number one, all dependencies that would be either compile or runtime. There's another category called runtime. So like if I had a JDBC driver.
Is that another typo, by the way? Is that class meant to have two S's?
Yes. This is a mass pair programming exercise, so you guys you're doing your job. Thank you. Yeah, so anyway, runtime class path has all of the runtime and compile time dependencies, plus all of the outputs of the compiler. So it's all the stuff that I'd need to run. And now, trailing new line. Isn't that great? Let's change the code again. And run again. Oops. You can't appreciate Shakespeare until you have read him in the original Base 64. Yes. So there you go. Basic dependency management, a really simple Java project. A couple more things. Let's take a look at our agenda. Where did that agenda go? Here it is. All right, we looked at Java, we looked at dependencies, we looked at task types. Now, if you wanted to know more about the Java exec task type, you'd go to the DSL documentation. And you'd scroll down the side here, and you'd see container types, help task types. There's quite a few of these. Antler, check style, code narc, copy. That's a very fundamental task that lots of other task types extend from. There's a hierarchy of task types. And then I would finally want to see, oh, there's Java exec. And there's all the properties I could have. So if I need to pass arguments to the main class, if I need to pass arguments to the JVM itself, I can do that. plug in environment variables. I mean, I've got stuff that I can do. So plenty of properties. I don't remember if there are any methods. No, there are a few methods. Yeah, okay. This is a typical Gradle idiom. There's a property called args, and so I could, in some parallel universe, say like that. And I'm actually going to build up to that in a minute, where I tell it what method to run. And I'm assigning a value to a property. Non-groovy programmers, number one, if you don't use any groovy, we can still be friends. But that's a list literal. So that's like making a new array list and adding something to it. It's just better. So here, args is a property to which I am assigning a list. You'll notice in the docs, it also says there's a method called args, which means I could do that. I could also pass that to that method. So this occasionally yields some screwy looking code where if you don't know your groovy real well, maybe you can't tell that that's a method call because the parentheses are optional. And you're like, well, I saw it in that other build where it was equals, and here there's no equals, and why is the equals optional? The equals is optional because typically properties also have method versions, so you can not have the equals. So be on the lookout for that. All right, we don't have args yet, so we're just going to take that away. I was looking at our agenda, tests, probably not. The wrapper. Let me show you the wrapper. This is kind of neat. Over here. Now, if I push this up to GitHub right now, here, let me see, I'll touch .git ignore. I got .gradle and build. I want .gradle and build to be ignored. Looks great. Add that stuff, and I'll say this is my initial commit. We're done. I've got a Git repository. I push it up to GitHub. I say, check out my poetry emitter. Go clone the project. And you don't know anything about Gradle. And the README says, well, go download Gradle and figure out how to install it and mess around with it. And that's kind of a barrier, right? Or what if it's a sophisticated build that relies on features of the latest version? And you're back on 1.6. I think I'm running 1.6 right now. We're on 1.8 now. So it needs to be 1.8. I say, well, sorry, install the version I want. That can be a problem, all right? In an enterprise build, you want to be able to lock the version of the tool, but you might want different teams and different projects to be able to adopt different versions. You don't want to lock everybody into the one thing that you've got. That's what the wrapper is all about. Let me show you how this works. I'm going to go into my build file and create another task called wrapper, and I'm going to give it the type wrapper. So this is a task type, and task type is wrapper. This, of course, could be anything. That's not a magical name, but I'll keep it as wrapper. And I'm going to give it a version. I'll say 1.8. Now, my Gradle version is 1.6. That's what I've got installed. But if I run the wrapper, what just happened? Well, let me ask Git what happened. According to Git, I have a new directory called Gradle and a file called GradleW. That's what the wrapper does. Let me just go ahead and add those. There's not much to the Gradle directory. There's a tiny little jar and a properties file. Now this jar has just barely enough HTTP client to go out to the web, or look in the Gradle wrapper properties file, go to the web and download Gradle 1.8, unzip it, and cache it in the .gradle directory. So the wrapper, added wrapper for 1.8. Now when I run GradleW, I'm getting Gradle 1.8. I can still say that the natively installed version of Gradle is 1.6. but the wrapper is not. And now I can just push this up to GitHub and say in the README, download it, build it with Gradle W. It's great. And the first time somebody does that, sure, there's a 45 megabyte download of Gradle and all the stuff, but that's not that big of a deal. It just happens once, and from then on, they're always using 1.8 until you rev Gradle. If you want to go to 1.9, then the next time they pull, they're going to be running 1.9. It'll download 1.9. It'll cache that. You have control over the build. So in the enterprise context, builds are repeatable. In an open source world, you don't have to push Gradle installation on somebody. Gradle does it for you. I should tell you a little bit about custom plugins. Yeah, let's do that. Let's do that. So we'll go to code, Liquibase, Gradle plugin. Now, yes, and I should also go to workshops, Liquibase. It would be nice, Liquibase is this tool I've worked with a lot in the past that does versioning and kind of a collaboration tool for relational database schemas. So if you want a development team to be able to refactor and iterate on the schema and control the version of the schema with respect to the code, Liquibase is a tool that does that. But it's a command line utility, and it's, you got to have some way to run it, and I would want to be able to automate that into my builds, which means now my builds, in addition to knowing about directories and compilers, need to know about database credentials and JDBC URLs, and they have to point to Liquibase change logs and all these things. You need a custom plugin for that. So basically, all of this stuff right here in the middle, that's not a standard part of Gradle. That's new Gradle DSL, new build language that I added through a custom plugin. So what plugins really do is, I think the best way to think about them is they extend the DSL. The Gradle object model now with the Liquibase plugin installed knows about databases. What's a database? Well, it's a thing that's got a URL and a username and a password. You don't really want a password in here for anything but the sandbox. So I would use other facilities of Groovy or of Gradle to get that password into some other file out in the environment, or an environment variable that I'd read. I wouldn't actually have it in the file. I have that flexibility. But the fact that I now have a domain object called a database and a named collection of them is a thing that my plugin does. Likewise, a Liquibase changelog, which is a file that lists all the changes that have happened to the schema. That's another domain object that the build is able to be aware of. Plugins do basically that. They don't, kind of the Ant task mechanism, to be able to write custom Ant tasks, was a very successful extension mechanism. It was a way of taking lots and lots of imperative code and bundling it into one line. And that's good. That's better than doing all that in XML. Okay, that was a big win, and there were all kinds of Ant tasks written that did lots of cool things. You've got that here. There are tasks that you don't even see in this build file. They're just tasks that the plugin introduces into the build, just like the Java plugin did. So there are sequences of imperative operations, things called like generate changelog and changelog sync and update and roll back to SQL and strange things like this. That's all there. Also, though, new language, new domain objects. If you're a programmer and you're faced with new complexity, that looks more like how you manage it. You come up with things that have simple names and you hide functionality behind those simple names. That's Gradle's extension mechanism and Gradle's scheme for managing complexity. Do you have questions about Gradle? I've given you just a whirlwind of tour of a few features here. What would you want to do? Yes?
Can you run Ant tasks?
Yes, Gradle is a superset of Ant, so you can run Ant tasks. There is a built-in, in every Gradle build, a built-in, Ant builder object. It's called Ant, so I could say ant.import build. The the ant build file, and all of the targets in that XML file have now become Gradle tasks. So that's very simple. The nice thing is that the ant domain model is so simple, and it happens to map as a subset onto the Gradle domain model, that you get away with this crazy integration that does all kinds of great things very well. Now, is there an import pom.xml that works quite that well? Not quite. That's different, because the Maven domain model is fundamentally different from the Gradle domain model. There probably won't ever be, some kind of automatic round trip, everything will get converted beautifully in one step process. There are tools that help automate the conversion. There are tools that will automatically read in POM dependencies and make them into Gradle dependencies, but the full scope of converting a Maven build is probably more work. And frankly, if it's a complex ant build, I've done this, you probably do have programming to do and thinking to do to convert to this data model, to do well at it. But to get started, this works.
It's just if you've already written a bunch of custom ant tasks, it gives you a quicker way into it.
Quicker way into it, exactly. So you want to stick with that, keep that investment in those custom tasks, and then you're probably going to find that the good Gradle build over time, you're going to want to rewrite them a piece at a time, and you do the migration more comprehensively, but you start with that import. Anybody else?
I have a question. So this task poetry type Java exec, is there an implicit rule that compile tasks get executed before that?
Thank you. Yes. Is there an implicit rule? Such a good question. Is there an implicit rule that the code is going to get recompiled when I change this? So let's find out. I'll go to poetry emitter and I'll change this to po, and I'll simply run poetry again. And it's base 64, so we can't read it, but it's 6 lines, so yes. And we see that compile Java was not up to date. Why is that implicit? Because, well, it's not explicit. So where's that magic come from? You need to know this, because it's going to work and you're not going to think about it. Just the right thing is going to happen, and you're going to love life. And then you're going to have your own tasks with your own explicit dependencies, and you're going to come up with a difficult dependency graph problem at some point, and you're going to be chasing through your build like, okay, this task depends on this with your explicit thing, and then you're going to come to this and you're like, wait, how is it even running? It's wrong, it's broken, it's magic. It is not. Basically, containers of files, which is what runtime class path is, know how they get filled up. This is a property of the internal Gradle API, the way Gradle is built. So runtime class path knows that it gets stuff put into it by compile Java and by process resources. And so if one of those becomes out of date, then poetry, its dependencies, it automatically gets wired to the things that fill up its file containers. And that basically works with the wiring of dependency outputs or build outputs and inputs among the task. It's magic and it works properly. But don't think of it as magic. Think of it as part of the machine that's wired up that way intentionally. Probably time for another question before we... Sir?
Fairly, that one, is there any reason to use Maven and not Gradle for specific cases?
Got it. Is there any reason to use Maven and not Gradle for specific cases? No good ones. No. Yes, there are. And specifically, if you're currently using Maven and you're not suffering because of it, I don't have a strong argument to move to Gradle. I would say if your build works and there's no pain, you probably have other things that you need to do besides your build, so go do those. Don't worry about it. So mostly my message is for people who are experiencing pain, and there's a well-defined time when that takes place, when the model of your build, the implicit domain model of your system, is too different from Maven's domain model, then the fun's over. It goes from I love Maven to I hate Maven basically overnight, because you all of a sudden really just can't do new things anymore. And when that happens, you need a place to go, and Gradle is what I recommend at that point. But you're the only one who knows that. If you're using Maven and it feels good, don't stop. It's a good tool. It just is a bad tool when it's a bad tool. Can't argue with that.
It's very flexible.
Maven is inflexible. Exactly. And that is an opinion and a design decision of the tool. It's proud of that, and it thinks your build should look like it thinks a build should look. Gradle also kind of suggests that your build should look a certain way. If you think it should be different, Gradle says, well, that's cool. Do what you need. One more question.
You know those Maven multi-module projects when you have a parent
Yes.
and you have subset of
course.
projects, and it's kind of difficult to keep a tracking of the parent versioning. How can I improve that using Gradle?
Right. So the question really is, how do multi-module builds work in Gradle? And the answer is they do. I don't have time to live code all this tonight, but basically what you're going to do is you're going to set Gradle up in multi-module mode. There's a file called settings.gradle that you create, and in settings.gradle you tell Gradle where those other sub-projects are, or peer projects, or whatever they are. And now what Gradle's going to do is, instead of just reading one build.gradle file, it's going to look for all of those build.gradle files. And each one is basically able to reach into the object model of another. For example, if I had a project called codec with the codec stuff in it, I could go reach into that project and compile time depend on all its outputs. Or if I wanted to reach into, if I had one called content, I could go configure that and say, guess what, you now have a dependency on this. Or if I wanted to say, I tell you what, all projects you all have Maven Central as your only repository. In a multi-module build situation, I'm not just programming one builds project. I can reach into all of them. They're all kind of an interactive thing. So that multi-module build builds a graph of project objects, each of which has its own task graph that can get executed. So it's a pretty dang flexible situation. All right. Well, I'm going to stick around for a few minutes. So I know it's getting late, and if some of you have to go, I want to respect that. But I'll hang around if you want to talk more about this or whatever. I'm going to be here, and I'm glad you were here. And I want to say thank you. We still have some things to give away, so don't run yet. But thank you very much.